Hey everyone, it's Miss Panganaban here, and we're going to be going over factors and multiples today. Um, this is going to help you so much when you are multiplying and dividing. It's really what will help you do this fluently and quickly. So we went over our standard in the slide deck, but our I will statement is I will gain familiarity with factors and multiples, and we're going to be especially focusing on what a factor is. You probably are very familiar with what a multiple is, and it is a bit easier to identify, but factors is maybe not as simple. So let's go ahead and jump right in. So we're going to go ahead and start with what is a multiple? Okay, and you probably know what this is. You just didn't put the two and two together with the name of it. Okay, so a multiple is the product of a number when it is multiplied by other numbers. Okay, and we have gone over these in class, and you do them all the time when you do your multiplication. It's just a matter of putting the name next to it. Okay, so let's go ahead and start with, we can start with 1 just because it's simple. All right, so if my example is the number 1, okay, a multiple is the product of a number, so this number, when it is multiplied by other numbers. So if my example is 1, a multiple would be when I multiply my number by other numbers. So I'm just going to go down the list. 1 times 2, 2, okay? And this may start to look familiar with what we do in class. 1 times 3, 3. 1 times 4, 4. 1 times 5, 5. Okay, sound familiar? These are your multiples. And these are the multiples that we sing in class and that we recite when multiplying larger numbers. So 6, 7, 8. So we typically stop at 12 or 10. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that one's pretty simple. These are the multiples of 1. So if I say, what are the multiples of 1? That would be 1, 2, 3, 4, 5, 6, and so on. Multiples of 1. Okay, so pretty simple here. So if I say, what are the multiples of 2? You are just counting out your 2's. Multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right? So that is what a multiple is. And we do have multiplication songs for some of these. So I'm just going to finish writing out some examples, and then we're going to be moving on to factors. Okay, so 1s are simple, 2s are simples. Let's go ahead and do, how about 3s? So let me separate that so it doesn't get confusing. All right, let's do our 3s. So same thing. Here's my number. And a multiple is a product. So I know that I need to multiply. So let me put that in. Product of a number when it is multiplied by other numbers. So let's go 3 times 1, 2, 3, 4, 5, 6. All right. So we have 3, 6, 9, and 12, 15, 18, 21, 24, 27, 30, 33, 36. Okay, so that's our song that we sing with our 3s. Those are multiples of 3. If someone were to ask you, what are the multiples of 3? You would recite those. Okay, and it's just 3 times 1, 3 times 2, 3, 4, 5, 6, 7, 8. Okay, and so on. All right, so let's go ahead and do our 4s. And we're going to go ahead and, instead of writing all this out, I'm just going to write my multiples out and sing the song. Okay, so here's my next example. What are the multiples of 4. Here we go. So we know that 4 times 1 is 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16, right? 4 times 5, 20. You're just adding 4 each time. It's repeated addition. So now the word for multiplication, repeated addition. 4 plus 4, 8. Plus 4, 12. 12 plus 4, 16. 16 plus 4, 20. 20 plus 4, 24. So that's 1, 2, 3, 4, 5, 6. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. 4 times 7, 8, 9, 10. We're going to stop there, but I'll go ahead and sing this song. So the song that goes with this one is 4, 8, 12, 16, and 20, 24, and 28, 32, 36, and 40, 44, and 48. 4 times 12 is 48. 4 times 12 is 48. All right. We're going to go ahead and we'll just do a few more. So we know our 5's pretty simple. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Those are just going up by 5. So let's go ahead and do our 6's. And then I'll also include the link for the song so you can practice those as well. So 6's. Okay. If you recite your 6's, 6. 12, 18, 24, 30, 36, there's more. 42 and 48, 54, 60, that's great. 66 and 72, I know my 6's, how about you? So these are the multiples of 6 all the way up to 6 times 12. All right, one more. Let's see. Let's do our 7's, I suppose. All right, multiples of 7. Let's see. 7, 14, 21, and 28. 35 and 42 and 49. 56 and 63 and 70, 77, 84, or. So those are my multiples of 7. So the way to read this, what I've drawn here, so I know that 7 times 6 is 42. Really simple. 6 times 9, 54. Okay, 3 times 5, 15. 4 times 7, 28. So multiples are the product of a number when it is multiplied by other numbers. Okay, and you guys should be pretty familiar with those. We're going to go ahead and move on to factors. What is a factor? All right, so we've gone over what a multiple is. Now let's go ahead and do the inverse of that, which is a factor. So what is a factor? A factor is a number that goes evenly into another number with no remainder, okay? Or another way to put that is factors or factor pairs are numbers that are multiplied together to get a product. So we have factor times factor equals product, okay? And for example, we're going to use 12. So we want to find all the factors and the factor pairs of 12. Okay, so the best way to do that is to divide, and you start by dividing by 1 and seeing if that can go evenly into 12. So if I do 12 divided by 1, then I get 12. 1 times 12 equals 12. Factor times factor equals product. Factor times factor equals product. This is our first factor pair. Can 2 go into 12 evenly? So if you know your multiples super well, then your factors will get so much easier. So I can just say my multiples of 2 and see if 12 is one of them. 2, 4, 6, 8, 10, 12. Hey, look at that. It goes evenly into 12. So yes, 2 is a factor of 12. And 2 times what equals 12? Or the inverse of that, 12 divided by 2 equals 6. So think of this like a math mountain. So if I had 12 at the top, 2 at the bottom, what would I need to multiply 2 by to get to 12? All right, let's see if 3 can go into 12. So let's do our multiples of 3. 3, 6, 9, and 12. Hey, look at that. It went in evenly. And how many times? 4 times. So there's our next factor pair. 3 times 4. Then I would check 4, but since I already have 4 here, I don't need to go past that. Once you get to a number and you were to repeat it again, you're done. Okay, so I could just show you that really quickly. If I did 4, of course, that would go in 4 times 3. 5, 5, 10, 15. Nope, doesn't go into 12 evenly. 6, 6, 12. Oh, look at that. I already have that. See how it's already repeating? Once you get once this number is going to be your next number, you're done. Let's check 7. 7, 14, already too much. 8, 8, 16, too much. 9, 9, 18, too much. 10, 10, 20. Okay, so you can see that once you are here and this would be your next number to check, you're done. Let's go ahead and do another example. So if I want to find the multiples, or I'm sorry, the factors of 8. Okay, you're always going to start with 1, and 1 is always a factor of every number because you can always make a number by multiplying 1 by that number. So 1 times what equals 8? That's right, 8. 1 times 8 equals 8. Let's check 2. 2, 4, 6, 8. Hey, that goes in there. How many times? 4. So 2 times 4 equals 8. Okay, so factor times factor equals product. 3, 3, 6, 9. Too far. Okay, 4. Oh, check it out. We've already had it. Guess what? That means we're done. So if I ask you, what are the factors of 12? Factors of 12. All you would need to write out is 1. And then typically you want to put these in order. So it would be 1, 2, 3, 4, 6, 12. Those are my factors of 12. Factors of 8, 1, 2, 4, 8. 1, 2, 4, 8. Great. Let's try another. How about 16? Okay, so we know that 1 always can go in there. How many times? 16, because anything times 1 is itself. Okay, how about 2? 2, 4, 6, 8, 10, 12, 14, 16. How many times? 8. So 2 and 8 are factor pairs for 16. And this is when it's super important to know your divisibility rules. So in order to see if 2 can go into any number, it has to be an even number. So any even number you can think of, 2 can evenly go into there. Okay, how about 3? Okay, in order to see if 3 can go into a number, a trick is to add your digits and see if 3 can go into that number. So what's 6 plus 1? 7. Can 3 go evenly into 7? 3, 6, 9. No, it doesn't. So it should not go evenly into 16. So let's double check. 3, 6, 9, 12, 15, 18. Already over. So it does not go into there evenly. How about 4? See. 4, 8, 12, 16. And how many times was that? 4. So 4 and 4 are factor pairs there. And like I said before, once you've repeated your number, you're done. So if someone were to ask you, what are the factors of 16? You would say 1, 2, 4, 8, 16. Okay, so I've just for some reason at the top of my head, I have chosen all even numbers. Let's go ahead and try an odd number. How about 25? You might think at the top of your head, well, I don't think anything's going to be able to go into that besides 1 and itself because it's odd. Well, let's see if something else can go into that evenly. So we know for sure that 1 can go into 25. How many times? 25. How about 2? You should know automatically that 2 cannot go into 25 because 2 can only go into even numbers, and 25 is an odd number, so we're not even going to check 2. How about 3? See, remember what I just told you. A trick is to add these numbers and see if 3 can go into that. So 5 plus 2 equals 7. Can 3 go equally into 7? No, so we're not going to check that. How about 4? Let's see. 4, 8, 12, 16, 20, 24, 28. So no, 4 cannot go into there. 5. Ooh, think about that. If you know your divisibility rules for 5, you should know that 5 can go into any number that ends in either a 0 or 5. So we have 5, 10, 15, 20, 25, 30. Notice all those numbers end in either a 0 or a 5. So check it out. This number ends in 5. That means that 5 can go into there. How many times? 5, 10, 15, 20, 25. 5 times. So, although there aren't as many factors as there were, like for say a number like 12 or 16, there still are factors and there are factor pairs. Okay, so if someone were to ask you, what are the factors of 25, you would say 1, 5, and 25. Okay, these are all composite numbers. I'll go into that a little bit more another time, but composite numbers are numbers that can be divided by a number besides 1 in itself. Okay, so 12 can be divided by 1, 12, 2, 6, 3, and 4. 25 is composite because it can be divided by 1, 25, and 5. Okay, let's go and do the opposite of that, which would be a prime number. A prime number is a number that can only be divided by itself and 1, nothing else. So let's try 13. If someone were to ask you, what are the factors of 13? Is this prime or composite? Well, we all know that 1 can go into all the numbers. So how many times? 13. Okay, let's see if anything else can go evenly into 13. So we have 2. Well, I know that 2 can only go into even numbers, and 13 is an odd number, so I know it can't go into there. How about 3? Well, I know if I add 3 plus 1, that gives me 4. And can 3 go into 4 evenly? No, it cannot. So 3 can't go into there. How about 4? I have 4, 8, 12, 16. Can't go into 13. 5? 5, 10, 15. Nope. How about 6? 6, 12, 18. No. Uh-oh. 7, 7, 14. 8, 8, 16. No. 9, 9, 18. 10, 10, 20. 11, 11, 22, 12, 12, 24, 13, 1 and 13. So those are my factor pairs, 1 and 13. That means that this is a prime number. Nothing else can go into there. So if someone were to ask you, what are the factors of 13, you would only have 2. Just 1 and 13. Okay, so that is a review of factors and multiples. We'll be practicing that this weekend, next week. All right, let us know if you have any questions. Thank you so much for your time.